Hi, so this is the continuation of our discussion earlier. Let's just have a very quick review on the i's. Again, the i's are a cycle, or it's a cycle repeating after the fourth power. So I want you to always memorize this part because this will be very helpful as you solve the powers of i's to the I to the fourth. Okay? So we'll move forward, but this time we'll try to operate the values of the imaginary numbers. Let's start with finding products. So when you multiply, always remember numerical to numerical and then imaginary to imaginary, which means 4 times 7, that gives you 28, and then I squared. Again, you don't stop here because squared, remember we follow the form BI, which means you're not allowed to have an exponent of I greater than 1, and you have to simplify that. Going back to your concept of I squared gives you a value of -1, right? So it just gives you a simplest form here of 28 times -1, which gives you a final answer of -28. Again, always remember, you do not stop until your values are in the form a plus minus bi. Is it okay to end up with just an a or just a bi? Yes, it's okay. You might end up having a complete form a plus bi. Sometimes you might end up with just an I, or just an imaginary, or just a real part a. And in this case, you ended up with only the a form, okay, which is -28. That's okay. So let's multiply now. Number 18, you have -4 times 2, that gives you -8 times -9, that gives you 72, which is positive. And then you do the i's, that gives you I raised to 3. Always remember, we don't stop here. We want to simplify the I cubed, and we know that I cubed is just a -I. So if I multiply that to 72, then your final answer ends up as -72I. So in the second example, it ends up with only the BI form, and that's okay. All right? So again, rules of exponents. We know that if a certain expression is raised to the 3, we give that to both 2 and I. So this gives you 8I cubed times 5I. Simplifying that, you get 40 for the numerical coefficient, and you get I to the fourth. You know that I to the fourth is just 1, so that cancels out, right? That gives you 40 times 1, which gives you a final answer of just 40. Okay, same goes if it's a radical, which means you have to square the numerical or the real part and then the radical. So this gives you an I squared times 3 times 64 times I squared. Now notice that I squared is just giving you negative ones. So the first factor gives you -3 times the second factor, which just gives you -64. So multiplying these two, you end up with a positive 192. So this time we're trying to multiply, but we have two radicals in our examples here. So always remember, it applies to radicals as well, but we have to make sure that we express them in simplest radical form. So if we take a look at 18 first, 18 here can be simplified as 9 times 2, right? And 9 is a perfect square. Knowing that it's in a radical sign, this gives you also a -1. So the things that you could extract here would be 9 and -1, which means that the first factor will give you 3i being extracted, square root of 2. And then here, since this is just -10 times 1, 10 times -1, you end up extracting just the -1, which means this is just I squared of 10. So when you multiply that, you end up with 3i times I, you got 3i squared, and this is times square root of 20. You don't stop there because you notice that 20 is just 4 times 5, and 4 is something you could extract outside, which means this is giving you 2 as a numerical, which gives you now a 6 as a product. But I squared is a -1, right? So your numerical coefficient gives you a -6 because extracting square root of 4 gives you 2. 2 times 3 is 6, and I squared is negative 1, therefore you got negative 6. And then from there, you're only left with 5 inside that radical sign, and that's your final answer. Okay, now let's try to simplify 24. What largest factor you could think of 24 that 1 is a perfect square? That could be 6 times 4. Don't forget that negative 1, you could extract that. So simplifying this radical in imaginary form will give you 2i square root of 6. And that's something you multiply by, you could extract the I here, which gives you I square root of 3. And the other one is I square root of 2. And then let's try to multiply them. You end up having 2i times I times I. That gives you 2i raised to 3 times square root of, what is 6 times 3? 18 times 2, that gives you 36. So I squared here, if you notice, will just give you a value of negative I. So this can be simplified as negative 2i. But notice that 36 is a perfect square, so you could extract that with the negative 2i, which gives you negative 2 times 6. Therefore, your final answer is equal to negative 12i. That's your final answer. Okay, now the first part is basically multiplying. And when you're doing adding and subtracting, always remember that you're only allowed to combine terms that are common terms, meaning if it's an I term, that can only be combined with an I. If it's a real part, you can only combine that with a real part. So if you take a look at this, negative 11 and 9, that gives you negative 2. And then 3i, 2i gives you a positive 5i. And that's already in the simplest form, a plus bi. So same goes with number 2, 4 plus 7, that gives you 11. I negative 5 gives you negative 4i. Okay, but that's the case when you're adding them. When you're trying to subtract them, you have to be very careful because you're trying to distribute that negative sign to the second addend, right? So make sure you rewrite it first. You have 7 minus 2i minus 2 minus 6i. And that's the time you have to combine them. So 7 and 2 are the real part. You get 5. Negative 2i, negative 6i gives you negative 8i. And once you arrive at that a plus bi form, that would be your final answer. So same with example 4, you want to try to rewrite it first so you won't be confused with the signs, right? So distribute that sign for whatever factor or for whatever parenthesis that you have. So you end up having 6i minus 14 plus I plus 5 minus 3i. And then you combine all the real parts first. You have negative 14 and positive 5. That gives you a sum of negative 9. 6i plus I is 7i. Minus 3i gives you a positive 4i. And once you arrive at that a plus bi form, that will be your final answer. Okay, so for the next items, you're asked to simplify the expressions below and finalize your answer in the form a plus bi. So look at number 5. Number 5 is a product. So these are all multiplying, right? So let's do that. Let's multiply each. You have 2i times 8, that gives you 16i, minus 2i times 3i, that gives you 6i squared. Remember here that I squared is just a negative 1. So if you get the product of negative 6 and negative 1, that just gives you a positive 6. So you end up having 16i plus 6, but always remember to write it in the form a plus bi. So this is the real part that should go first. Okay, that's it. Number 6, we have negative I times negative 2, you got positive 2i. Negative I times 10i, you got negative 10i squared. Again, I squared is just a negative, so if you combine these two, this cancels out. This becomes a plus 10, right? And then you have to rewrite it in the correct form. You end up having 10 plus 2i. So for number 7, you have here same, but you're using two factors that are binomials. So you have to make sure you do the right thing when you distribute everything. Some of you might use the box method. We could do that. So let's say I have here 7 plus I, and this is 4 minus I. We just do the box. 7 times 4, that gives you 28. 4 times I gives you 4I. 7 times negative I gives you negative 7I. I times negative I gives you negative I squared. So notice again that here I squared is just a negative 1. So it's like a negative 1, which is giving you just 1. Combining that with the real part 28, you end up with a real part which is a sum of 29. And then combining all the imaginary parts, you got 4 and negative 7i. That gives you negative 3i. So you end up with this form. Okay, let's do the box method again for this number. You got 2 minus 4i. Okay, and then we have negative 5 minus 3i. 2 times negative 5 is negative 10. Negative 4i times negative 5 is positive 20i. 2 times negative 3i is negative 6i. Negative 4i times negative 3i gives you a positive 12, but there's an I squared. Again, remember I squared is just a negative 1, so that gives you a negative 12 for this box. So we combine the real parts first. We have negative 10 and negative 12. That gives you a sum of negative 22. And then we have 20i minus 6i. That gives you a sum of 14i. That'll be your simplest form. So always remember, when you are squaring a binomial, this is just a way of rewriting 6 minus 2i times the same factor, which is 6 minus 2i. So you could do the same method. We have 6 minus 2i here, 6 minus 2i here, and get the values inside those boxes. 6 times 6 gives you 36. Negative 2i times 6 gives you negative 12i. 6 times negative 2i is negative 12i. And then 4i, this will be negative 2, that gives you a positive 4, and then you have an I squared. Again, I squared is negative 1, so this box gives you a negative 4. Combining that with the like term 36, that gives you a real part, which is 32. And then combining both negative 12i, negative 12i, that gives you negative 24i. That's it. All right, so for this first two part, there's a product first before minus. Again, your rules in GEMDAS follows that you have to do the products first. So let's do that. Let's use another box method for that. You have there 1 plus 7i, and you have 9 plus 3i. Okay, 1 times 9 is 9. 7i times 9 is giving you 63i. 1 times 3i is just 3i. 7i times 3i gives you 21i squared. Again, I squared here is just negative 1, so that gives you a negative 21. So when I simplify the first one, that just gives you 9 minus 21. That gives you negative 12. See, negative 12 for this part. And then you have 63i plus 3i. That gives you plus 66i. Okay, so I'm going to rewrite everything here. So I have negative 12 plus 66i. Don't forget to distribute that negative sign. That gives you negative 4, negative 2i. And then we combine the like terms. Negative 12, negative 4. That gives you negative 16. 66 minus 2. That gives you plus 64i. And again, that's already in that form. Okay. So the first few parts are basic operations on adding, subtracting, multiplying. This time you want to multiply complex conjugates. And what are these complex conjugates? If you have a value of a and then a value of bi and you have a plus sign, the conjugate is just the same a and b, but this time it's a minus sign. Okay, so these pairs that you're seeing here are what you call conjugates. Okay, what happens when you multiply the conjugate values? Let's move on and start multiplying them. We have 8 plus I, 8 minus I. So the first box will give you 64, positive I, negative 8I, and then this gives you a negative I squared. Again, I squared by itself is negative 1, so that's a negative of negative 1, which gives you a positive 1. And then that positive 1 goes with 64. That gives you 65. And notice that these two lower left and upper right cancels out because they are just additive inverse. So we cancel that out. You ended up with 65. Okay. We do the next thing with the same method. We have 3 minus I, 3 plus I, and then we do the box again. We have 3 times 3 is 9. We got negative 3i, correct. And this one gives you a positive 3i. And then this will give you negative I squared. I squared is negative 1. Negative of negative 1 is just 1. So the real part gives you a sum of 10. And then again, these two cancels out. Now what have you noticed as you try multiplying conjugates? That the I values are canceling out, right? So another way to see that is just you're basically getting the product of the first two terms and getting the product of the second terms, and subtract them, right? So this one can be rewritten as 8 times 8 is 64 minus, what's the product of I times negative I? That's just negative I squared, which gives you negative 1, negative 1. So this just gives you plus 1, right? So that gives you 65. Okay, so let's do again the next one. Let's try to do that short method there. You get 5 times 5, you get 25. Negative 4i times 4i gives you negative 16i squared. You're just basically solving that. Because you know, as you do the box, it ends up canceling out, right? So you have 16i squared. Know that this is negative 1. So this just gives you a plus sign, which therefore gives you a 41 as your final answer. Now for the last item, let's do the shortcut and let's do the box method. Let's do the box method first here. You get negative 7 plus 2i, you got negative 7 plus 2i. So negative 7, that gives you 49. 2i times negative 7 is negative 14i. Negative 7 times 2i is negative 2i is 14i, right? And then you have 2i, negative 2i, that gives you negative 4i squared. I squared again by itself is negative 1 times negative 4 just gives you 44, just 4, and then add that, you end up having 53. So we should expect to have 53. So let's do the short method. By multiplying first term times first term, that gives you 49. And then from there, let's also multiply 2i times negative 2i, that gives you negative 4i squared. Notice that this gives you a negative 1. And then negative 1 times negative 4 gives you 49 plus 4, which just gives you the same answer, 53. Again, whichever method you feel comfortable, you may use any of it. So we're done with adding, subtracting, and multiplying. We're down to dividing. So when you're trying to divide a monomial, we try to multiply both the numerator and the denominator by the i's. So similar with radicals, when you remember when we have fractions and radicals, we're not allowed to have radicals in our denominator. Same with ratios of imaginary numbers. As much as you can, we want to make sure that we don't have an I values on your denominator. So what we do is we rationalize them, but for I, we basically multiply I over I, which is just a unit fraction, so we can rewrite it. This gives you 10i, and in the denominator, it gives you 2i squared, which later on, as you see, since I squared is just negative 1, the denominator will just be negative 2. And notice that it will cancel out the i's on the denominator, which gives you a simplest form of negative 5i. Okay, let's do the same thing with number 2. We just multiply I over I. Numerator is just 4i. Denominator will give you negative 9 times I squared. And I squared is just negative 1, so the denominator will give you a positive 9. 4i over 9. Okay. For some, they could rewrite it as a number first, time, and then added by the imaginary. Either way, I will accept both for the final answer. It'll be good. Next number 3, we do I over I again. But make sure here you're distributing it to a binomial, right? So we have I times 1, that gives you an I, plus 4i squared all over 2i squared. For the denominator, I squared is just negative 1, so the denominator gives you a negative 2. This is a negative 1 as well, which gives you a negative 4, and then this is I. Okay. Always remember, try to rewrite as much as you can the numbers in terms of a plus bi form. So remember, we should go first for the a form, which means negative 4 plus I all over negative 2. For some, if they notice that these two are negatives, they want to multiply negative for each term. So we could also rewrite this as 4 minus I all over a positive 2. Okay, that looks better. All right, let's do the next one. We do I over I for this one. 28 times I gives you 28I minus 8I squared. And then you have 4I squared. Notice that this will cancel out. This gives you a negative 4. And then this cancel out. This gives you a positive 8. Okay, so you end up having, let's rewrite it in the form. So you start with 8 plus 28I all over a negative 4. But notice that all of these numbers can be reduced by 4. They're all divisible by 4. So we can rewrite this. So what is 8 negative 4? That gives you 2. Right, negative 2. And then 28 negative 4, that gives you 7. Negative 7i. That will be your final answer. Okay, last part, guys. This would be what we call multiplying the binomials by its conjugate. So sometimes your denominators doesn't just have one term, but a binomial term. And in order for you to cancel that out, if you notice here in the first few examples, the numericals on the i's are canceling out here as conjugates. So when you try to multiply conjugates for this part, we know that that will cancel out as well. So if I multiply this by 5 plus I, which is its conjugate, over the same conjugate, which basically is just a unit fraction, you will be able to rewrite the fraction where the denominator does not have any I value. Okay, let's do the numerator first. Negative 2 times 5 is negative 10. You end up with minus 2i. That's your numerator. Let's try to do a box method here first. But since these are conjugates, you could also do the shortcut, which gives you just 5 times 5 gives you 25. Negative I times I gives you negative I squared, which you know is just 25 plus 1, which is 26. So we're expecting to have an answer of 26 as we do our boxed method. Let's do the long method for that. You have 5 minus I, 5 plus I. This gives you 25. Negative I times 5 is negative 5i. 5i here, that cancels out. As you see, negative I times I is just negative I squared, which is just giving you a negative of negative 1, which is just 1. And adding those two will just give you that same final answer. So it's up to you how you want to approach that one. If you're more comfortable doing the box method, that's good for you, then do that. But if it's easier for you to do the shortcut method, then it's okay too. So what's the conjugate of 6 plus 2i? Again, just copy the a, copy the bi form, and just give me the opposite operation, which is a minus. So you have 6 minus 2i here. We do the same thing. 5i times 6, that's giving you 30i. And then 5i times negative 2i, that gives you a negative 10i squared. I'll try to do a shortcut here because I squared I know is just negative 1. So this will be positive later on. And I'll cancel that out. Okay, I'll try to do the shortcut here. 6 times 6, that gives you 36. 2i times negative 2i is just negative 4i squared. Again, this is negative 1. So it will be positive later on as I cancel that out. Okay, simplifying that, you end up having, I'll try to rewrite it first in the form 10 plus 30i all over 36 plus 4. Let's do that. Sorry, let me erase that part. That gives you 40. And you know that all of these can be reduced by 10, all divisible by 10. So it'll be reduced by 1 plus 3i all over 4. And that will be your final answer. Okay, last two items. For number 15, let's do the box method here. So the conjugate of this one is just, again, copy A, copy BI, and then since it's plus, this gives you a minus. So we want to multiply that. Okay, for the denominator, we could use the shortcut just because we want to use the box method for the numerator. So 5 plus 5, these are conjugates. 5 times 5 gives you 25. 5i times negative 5i gives you negative 25i squared. You know that this is just negative 1, so that changed to a plus sign. And we know that the denominator is just basically 50, right? Let me rewrite that as 50. All right, and then let's do the box method for the numerator times numerator. You have 9 plus 6i. You have 5 minus 5i. 9 times 5 gives you 45. 6i times 5 gives you 30i. 9 times negative 5i gives you negative 45i. And then 6i times negative 5i, that gives you negative 30i squared. Again, this is a negative 1, so this will be positive 30. Combining that with the real part, that gives me 75 for my real part. Negative 45i and 30i, combining them will give you a negative 15i. And again, you notice that the numericals are values that can still be reduced. We can divide these by 5. So I end up with 15 minus 3i all over 10. Okay, and the last item, we have negative 8 minus 4i. Let's do negative 4. Be careful with that, okay? You just want to copy the a part, which is a negative number. You want a plus, which is its conjugate, 3i. Okay, so let's do the denominator here. So for the denominator, negative 4 times negative 4, that gives you 16, right? 3i times 3i, that gives you a negative 9i squared. You know that this cancels out to a negative, so this will just be plus 9. So this will just be 25 for your denominator. And then let's do the box method for the numerator, because there are two different factors. They're not conjugates, so it'll be a little different. So they got negative 8 minus 4i, negative 4 plus 3i. So we end up having 32, 16i, negative 24i, and then 12, negative 12i squared. You know that this is a negative 1. So this whole thing is just a positive 12. Combining these real parts, I know that the numerator gives me 44. And then combining the I parts gives me a negative 8i. Okay, so that will be 44 minus 8i. All right, this is kind of a long worksheet, guys, but everything is in here for all the types of operations, from adding, subtracting, multiplying, and dividing, different types of imaginary numbers. So I want you to go over this and try to review. Okay, we'll have more exercises after this. Thank you.